Thank you both for being here today. Welcome to the VMATYC virtual conference. And I want to introduce Jay Martin and Julia Smith. If you have any questions during the session, please feel free to enter those into the chat section at the bottom of the Zoom room screen, and we'll address them at the end of the talk. Without further ado, I'll hand it off to Jay and Julia. Thank you so much.
Okay, so we are, am I looking at this right? We actually have two participants, so TJ and help me with that name.
Evgenia, yeah.
Evgenia. Okay, awesome. Thank you for showing up to this. And so TJ already mentioned he's at the Blue Ridge Community College. Oh, here comes another one, Anna. So we'll do a quick
Tidewater.
I'm sorry?
I'm at Tidewater.
Gotcha. Where is that at located?
Chesapeake.
Gotcha. And Elizabeth just joined us. Elizabeth, where are you from?
Thomas Nelson in Williamsburg.
Okay. All right. And so we're having a few more coming in. That's awesome. Thank you so much. So with a small group, don't feel like you can't unmute yourself and jump right in. I'm going to share my screen for the most part. We have a Prezi that will get the information over to you probably the best way we can. And but let me give a little introduction to what we're doing, and I'll let Julia introduce herself and then we'll jump into it. But so I'm Jay Martin, WATE Tech for 36 years, Raleigh, North Carolina. So outside of Virginia. So thanks for hosting us into your state, and would love you to join us in the North Carolina VMATYC. It's usually in March in the spring. So I forget where we're having it this year, Southern Pines maybe. Julia, come on down and play some golf, ride some horses, and enjoy that area. But so we, Julia and I got a NSF grant for $500,000 right when the pandemic started. So we have yet to have a face-to-face meeting with our grant. So we've been on more virtual calls than I've been in a classroom for the last year and a half. But basically, we are taking high school math teachers and community college math teachers into industry, local industry, to find out what math do they use, and to give us some curriculum that shows our students, how math is used in the real workplace. In fact, they're building curriculum for us. We're taking their ideas and just minor massages and creating lessons to try to encourage all populations, especially underrepresented groups, into engineering programs that require 2-year degrees. We have such a shortage in Wake County, and I imagine that's across the whole US, for technicians and engineers with 2- and 4-year degrees. The job market is wide open, and we're trying to get this word out and show high school students and community college students, what these careers are like, what math is involved, and try to motivate why we teach them what we teach them. So I'm a PI on this, and Julia's a PI on this with me. Julia, you want to say a few words about yourself, and I'll jump into the.
Sure. Julia Smith. I've been at WATE Tech. This is my 8th year at WATE Tech, and before that, I taught high school for 10 years. Jay introduced you to the grant and what we've been working on. The grant is like the ultimate answer to the question, when am I ever going to use this? Which, I tell people, I tell my students all the time, I'm like, I use math every day. I don't know what you're talking about. And they don't like that because I'm a math teacher. So of course I use math every day, but so that's it. I'll let you take it away, Jay.
Okay, hopefully everybody sees a prezi here. It's got send me in today's goals, stormwater 2020 lessons and 2021 lessons. Do I get a thumbs up or a yes, I can see the screen?
Yes, we can see it.
Cool, thank you. All right, so right off the bat, we have a website with all the materials from the 2020 lessons. So what we're going to do today basically is kind of introduce you to what, and I've already done this already.
Jay?
Yes.
But would you put the website link in the chat?
Hey, Julia, could you do that for
Yep.
me?
I sure can.
Thanks.
Awesome. So, I mentioned our goals of our grant already. That was this slide right here, so I'll skip on through there. What I want you guys to get out of this today is kind of an overview of the format of all these lessons. We use Mathematics Vision Project, which is out of the National NCTM. It's a launch, explore, discuss, so it really encouraged student interaction. It's not chalk and talk and us teaching them how to do math in industry. They are involved, they are engaged doing these activities. So we're going to highlight one that shows you those 3 stages that all the activities are built around, and then I'll give you a very brief like a minute 90-second what each activity that we built last year is all about. So you can pick and choose kind of, man, that looks interesting or that one doesn't. They're all from the 2020 on our website, including the launch, explore, discuss pieces of them. So with no further ado, we're going to jump into the lesson that we're going to highlight the whole complete piece, and then we'll do snapshots of all the activities. So Julia, this is your part.
Yep, this is my part. All right, so I have to say this stormwater management one, it's probably one of my favorite lessons. It was actually the first one I did with my students last year. And at the end of this little piece, we actually have a video of my students. I asked their permission to use their video because they did such an excellent job on the discuss portion. But each activity starts with, we had to think creatively last year because we weren't expecting that any of this was going to be completely online, and all of it was online. We use this in our tech math course, our math 121 course. And I teach it purely online. I haven't had a seated section of it in years. But everybody was online last year. And so what I did was create a Desmos activity for the launch, because we weren't meeting our classes synchronously at all. We needed a way to launch the activity for them. So, and to get them started. So every activity starts with a Desmos launch. It goes over prerequisite skills. It includes a link to the launch video. In some cases, if they're going to need a piece of information that maybe you're not sure if they had in their past, you can use it to teach them a little bit of what they might need. We use it to teach vocabulary relevant to the particular industry that they're going to be exploring. So the Desmos activities are very rich. And that's really where the student starts. And at the end of the Desmos activity, they get their lesson score at the end. And I include that as part of their grade for the project. So they have to do it and they get a grade for doing it. So, yep, go ahead, Jay.
Okay.
So we also, as part of our grant, were able to hire a professional videographer to do 10 videos for us each year. So at the end of this, we'll have 30 videos done by our professional videographer. She's fantastic. We did 2 different versions of the video. One has a piece at the end specific to Wake Tech, where our program directors introduce their programs. And then there's another video that doesn't have that piece at the end. But what every video has in common, they introduce the company, they talk about soft skills. She interviewed a variety of employees at each company. And at the end, they launched the student tasks as though the students are the employees. And so that's what we're going to do now, is watch a little bit of the launch video for the stormwater management activity. This one was CLH Design, and go ahead, Jay, 540. Yep.
Architecture is inside the building.
When the rain's coming down, where are you sending it? That could really dictate how the site is laid out. Because if you need more space for a constructed wetland or a storm pond, then that kind of moves things around on the site layout.
When we talk about stormwater, there's two things that we look at. We have stormwater quantity, that's the amount of water, and stormwater quality. So it's the quality of the stormwater leaving our site. If we don't treat the water running off from our sites, that can affect the streams. And from a stormwater quantity point of view, we have to remember that we're tying into the existing stormwater system. So if we allow more water to leave our site than what it was doing previously, the downstream system might not be sized for that, and you can cause flooding. And if you're directly discharging into a stream, you can really erode that stream, and you can change the course of water to affect properties that before were not having issues. There are several strategies for stormwater detention. You can have very basic stormwater measures like a dry detention pond, which is just a hole in the ground with a pipe that slowly releases the water. Wet detention pond, those are the little ponds you see everywhere. You can have wetlands, which incorporate plants that will take the nutrients in the stormwater. You could have bioretention ponds that have special media that filter also the stormwater. The stormwater device that we choose depends on the site and the cost and what the project will allow for. You are hired to analyze the pre-development peak runoff and compare it to the post-development runoff to determine if you will need a stormwater measure for the site. The first thing you're going to need is to look at your pre-development drainage area and determine the type of land cover that you have. See if it has existing impervious, and impervious is any land cover that will not allow water to penetrate it. So it would be existing asphalt, sidewalks, buildings, anything like that. And we'll look at the ground cover that we have for the pervious, which is the materials that allow water to infiltrate. If the post-development peak runoff is greater than the pre-development, somehow you're going to have to detain that water and release it slowly so it matches the pre-development.
Two different wetlands. You got your natural wetlands that occur already by themselves, and then you've got your constructed wetlands. So the natural wetlands, typically we disturb them as least as possible. When it comes to construction wetlands, those are regulated by the North Carolina Department of Environmental Quality. So they have their standards that we have to go through, and they have select plants that they've chosen for certain areas of the wetland.
For this case, we decided to go with a wetland. You're going to have to use the percentage of impervious that's draining to that wetland, and you're also going to have to determine the depth of that treatment volume. And once you have those two things, you can determine the size of the wetland area that you need.
So when water enters the site, it's our responsibility to manage it. We want to make sure that we're making the water that's discharging into the creeks, streams, and rivers cleaner than when we received it on our site.
Okay, so that's what the end of the video looks like. And so after that point, the students would do anything that was left in the Desmos activity, but generally that's at the end. And they have launched the activity for the students and said, okay, your job now, you have two parts. Part one, do we need a stormwater management system? And then part two, they have to size the stormwater management system and answer a few questions about that as well. So this is essentially what they would be given on their explore task. They'd be given the introduction to CLH design, And they do specialize in school site development. Now, the school that they use, that is an actual, the South Lakes Elementary School, that's an actual school that they developed a stormwater management system for. So it's a school that they actually did work on here local in our area. And so they were contracted to develop the stormwater management plan for the elementary school. So your job is to analyze the pre-development peak runoff and the post-development peak runoff to determine if we need a stormwater management system. And we give them these two equations or these two formulas. One thing we do also in the Desmos activities, we explain summation notation because our students don't know that. But then it's up to them to then calculate the weighted runoff and the peak runoff. You want to go to the next one, Jay?
Sure.
Which is what I believe is on the next slide, right? Yes. All right. So our pre-development peak runoff. So I put a link also in the chat to the stormwater activity for today. And so I'm going to give you guys a little bit of time. You guys can talk amongst yourselves. You can talk to Jay and I, but I want you guys to see if you can calculate the pre-development coefficient and the peak runoff. So if you want, that link is in the chat. And it's got the formulas and everything on it. I'll be quiet now for a little bit unless you ask questions.
Let's see. So that numerator was AI times CI, right?
The sum of AI, CI. Yep. Over
divided by the total area, right?
area. Yep.
And then that final formula
Is C times I times A.
So C is the coefficient, which is coming from up here, times I, and I is,
I was given to us. Yep. That's our
Yeah.
rain intensity,
times,
the total area.
which is right there, isn't it? I love annotating in Zoom. It's so
I know
cool.
you do. It's I think it's your favorite thing to do.
So Julia, in the keynote, Dave gave us these puzzles that weren't so easy to solve. One of them I had heard of before, but and then he asked everybody at the end of that, how are you feeling now? And everybody said, I'm burnt out, my head hurts, I'm worn out from this. I'm having a hard time concentrating. So I don't know, audience, or if we had enough of this already.
Are you guys done? You ready to keep going? Or still thinking?
Let's go on.
All right. So C, our runoff coefficient is 0.9 or 0.1943. And then our peak runoff in cubic feet per second is about 4.8. So 4.8144. So before they build it, that's our peak runoff. Then after pre-development, they analyze post-development.
I was just thinking in Virginia, that 7.08 may be a different standard. Because that's really for
That's for Raleigh.
our area. Yeah.
That's for our area. Mhm. All right, so then they have to analyze the post-development peak runoff.
Same kind of thing, right?
It is exactly the same thing. So they get their C, and then so now their peak runoff has gone from 4 point something to 47 point something. And so it obviously increased since your post-development peak runoff is greater than your pre-development. You are going to need a stormwater management system. So the students would conclude, yes, one is needed. One thing though that came up that the students often ask about is that the area changed from pre-development to post-development. And they go, well, we have more area in post-development. And ultimately what happened when they were preparing the land for the site is more land needed to drain to the same spot. And so that's why the area increased from 3.5 acres to 8.7 acres. But yes, they do need a stormwater management system to handle the runoff. So then all right, so now that we know that a stormwater management system is needed, now we ask the students to calculate the required wetland surface area and volume before they can hand the project off to the landscape team. So they first have to determine what the percent impervious is. So the percent of impervious land that they have, ground covering. So they go back and they figure out within the wetland drainage area, how much of that is impervious and over the total area of the wetland drainage. Now, what they miss is that little star down there that says percent impervious. Use actual percentage, not decimal equivalent. So you use 4.5%. You would use 4.5, not 0.0425. And then also we're given some industry standards down there as well that they'll have to use. So they start by finding that percent impervious and they use that to come up with their runoff value. And then once they have their runoff value, then they can find the volume and the surface area. The design storm is given to them as 1 inch for Raleigh. And then the depth is given to them for surface area as well. This is a lot of composition of functions without students always realizing that they're using composition of functions. Yep. So the proposal is that somebody proposes they need 18,000 cubic feet. Is that enough? And so when they go through and they figure all this out, then they determine, well, no, it's not enough because we need 21,000 cubic feet. And so then they're asked to think about reasons like, or how they might handle some of that runoff since it's not enough. Like what else could they do as part of their proposal? And then that's where the student discuss part comes in. And then, so these are my students. Yep.
And I should mention, Julia, I'll brag on you. Like she mentioned earlier, we're doing this completely virtual with our students in online classes, and we're putting them groups of 3 students. Normally we build a private channel in Teams. We're using MS Teams at Wake Tech. So we're building, we're putting them in private channels where they can go and meet to discuss these solutions. And then for the most part, their presentation is they're just meeting on their team's channel and creating a video explaining their solutions like they're talking to the industry partners. So that process has worked really, really, really nice virtually.
It has. I will say I've had to, in some cases, because in some cases, like when you're in class, the class discussion, part of it might be explaining the math of how you got an answer. And online, I have tried to steer my students from this, because as much as I love math, I don't want to watch 5 groups tell me how they did the math to get to the answer. I see that in their work. And so some students have gotten super creative with it. This group, they did a great job already this semester in a different project. I had one group who did their presentation like they were at a board meeting for the company, and they answered the questions that way. So for my online classes, I've tried to keep the discussion questions to questions that would yield different answers, because I also make the students watch each other's videos and then they have to comment on at least 2. And I tell them their comments have to be something more than great job. They have to find something they can literally comment on from the video. So like if they get a different answer, they should say, we got this answer. Or if one group came up with something that the other group didn't, they can say, oh, we didn't consider, that aspect of this project or whatever. So, and at this point, the students, there's a stormwater management system is needed, and here's their proposal.
Number 10, in the previous question, we calculated out the volume required for our management system. The volume that we got is 21,106.09 feet cubed. So number 10 asks us, the architect team has design that provides 18,000 feet cubed of volume for the wetland. And we decided that this will not work because the volume that we need is 21,106. And when we calculate out that percentage increase, we need about 15% more volume than what they can give us. And then Brittany has a little bit more to expand on the design that we need.
So the proposal, we said, for the stormwater management, they should include a cistern below the parking lot, which is asphalt impervious area that would drain out and prevent flooding in that area. And then they'd also need to create a stormwater detention pond on the landscaped area for the runoff to be collected. And the pond must be dug below grade in an area in which like the runoff can flow, so downhill. And then in the chance of excess runoff due to a potential higher design storm, the detention pond must adjoin to the city's underground watershed system. That's our proposal.
So that was the first group that I had that did one of these, and I was blown away by what they did. They really thought about it. I mean, and so I was really pleased with what they did. All right, I'm going to hand it over to, I did see one question popped up in the chat. How long are their videos supposed to be? I don't give them a time maximum or a minimum. I give them a list of questions and they need to sufficiently answer the questions. And as long as they do that, then that's fine. Most of their videos, some are as short as 3 minutes and then some are like as long as 7 minutes. It just depends on how much talking and explanation they do in their videos.
And the launch videos are all about 7 to 8 minutes long.
Yes, the launch
those
videos
are
are
the professional developed. And the thing I like about those so much is it highlights a lot of different types of people. So like you saw in that last one, you had African-American young guy that actually has a architectural degree from Wake Tech, and you know, he tells his story a little bit in the middle of that video, which we kind of skipped over. So it's people in these industries that I think our students can really relate to, and they tell their story, which Dave talked about a little bit in the opening session. You know, if you can tell a story to students, they're a lot more attentive. And I think their videos, even though they're 8 minutes, that's getting a little pushing the envelope for time length. I think they're pretty engaging for the most part. Does anybody have questions from the audience at this point?
As Jay gets ready to talk about the list of activities that we have so far, you know, and he might have said this earlier, but if you're interested in trying any of them out in your class, we'd love to have you try them out and do the activities. We want to share them and we want people to use them. So hopefully as he's going through them, you'll find something that speaks to whatever course you teach.
Okay, so these are the ones that are really pretty clean right now. These are the ones on our website. We have a Desmos teacher activity. The link is there on the website as well. We've got the video, launch video on the website. We have the application or the task, and we also have teacher notes that give hints along the way on how to do the launch, explore, discuss. So these are completely finished from last year. And I'm just gonna, you know, quickly show you one slide from each one and try to keep it less than a minute. Because we end this in about 10 minutes anyway. So this is from mechanical, and the main thing they're calculating here is ventilation rates. So there are a lot of volume and occupancy calculations based on the size of the rooms. And they're also looking at heat or air conditioning loss through different surfaces on the exterior. So kind of a result here is windows typically are gonna, you know, lose about, could be up to 10 times the amount of energy that a exterior wall is gonna lose. So that topic uses basically algebra and a little bit of composition functions, even though they have no idea it's really composition functions. This is an architectural application, and they are designing a staircase to fit inside of a stairwell. So they're given the dimensions of the stairwell, the distance from bottom floor to top floor. There's code on the tread and the riser. Basically, that's rise and run on slope. I forget exactly what it is, but all that code is coming in to design the stairwell that gets you from bottom floor to the second floor. The extension here is kind of cool. We're putting a door under this landing. Like we're going up, we reach a landing and we come back up to get to the second floor. We're going to put an exterior door under that landing, which means we're going to have to raise it up a little bit. So they're doing a redesign on that, still keeping these code satisfied. So again, the map there is really just application of slope, rise and run, but some critical thinking involved for sure. Solar panels, this is one of my favorite uses, law of sines and law of cosines. Is presented to you on the video by your school is going to go green. You pick a building on your school. You could give them the dimensions, or they can go figure out the dimensions. But it's twofold here. One is you have to figure out the mounting bracket This here, there's like 5 different versions that you could buy. That's a length of a mounting bracket and an angle at which is joining the actual solar panel, which is right there. So based on the sunlight angle in your area, so that's the sunlight coming in, you have to figure out what bracket and angle are you going to use, and also what is this distance between the rows of the panels, so that the first row of panels has no shading at all on the second row of panels, and that you can determine how many panels you can fit on your rooftop. And then based on an energy usage per panel, we can figure out which way are we going to face those panels in order to generate the most energy possible. If you teach statistics, this is a great introductory activity in your intro stat course. It's coming from a biopharmaceutical company. They've given us data, and it's not true data just because of it's a biopharm. They're very sensitive on giving any kind of information out. But it's they are collecting or taking measurements off of samples of inhaler canisters, and the canisters are put together by crimping a dispenser to a canister, and that crimp diameter and height is measured, and also the net field volume is measured, and they have to be inside of tolerances that you're given. So the idea is they graph the data that you have, and they can graph like an upper tolerance limit and the lower tolerance limit to find out when is the sample out of tolerance, so they need to shut down production and look at, you know, fixing the machinery. So graphics primarily with intervals. This is wastewater. This is a tough one. It's twofold. It's application of quadratic regression, as well as finding intersections of graphics and using some type of technology. I think we use Desmos in the high school to find those intersections once they build the quadratic regression. But basically the first part is you have this area here, and there's housing development and an apartment developing. It all slopes down, so the pipes in the wastewater pipes is flowing down to a pump station that's down here. So we're sizing the pipe to handle that wastewater based on the number of houses and number of apartments. In this pump station, we're pumping all that wastewater up over a hill, or it could be to a treatment plant. If we have a treatment plant there, usually it's pumped up over a hill to another area that has also a drainage by gravity flow. So you're sizing the pump needed. These pumps are hugely expensive. The video's got all the pictures and graphics of a walk through one of those pump stations that are normally like 30 feet underground. And this is a graphic in a table that civil engineers have access to determine which pump they need. And so they're graphing a total dynamic head force on by the water to figure out the intersections of these pump curves, and then try to figure out which one is most efficient to purchase. Yeah, I meant to erase that. Okay, this is another biofarm industry application. If you do confidence intervals in a statistics class, it's also got some quadratic regression in it. But basically, we are trying to determine what temperature are we going to grow a virus in 4 different mediums. And in a medium, it took me a long time to wrap my head around that, but it's the substance that they grow these viruses in. And I think egg yolks is a possible medium. So it's whatever substance they're actually using to grow the virus. So different temperatures will grow the viruses at different rates. And so you're determining the best temperature that maximizes the yield. And you don't need calculus. You could do minus b over 2a because they are quadratic, or you could use Desmos or a graphing just to put your pencil on that high point. So we're not worried about the very exact vertex here. But also then they have some new viruses that are vaccines that they're going to try out, and they use confidence intervals to determine if we're going to stay with a current vaccine or we're going to go to a new vaccine that would have a better yield, and cost is involved here as well. So we're trying to get out under this cost of the current vaccine production. Again, I'm just trying to give you enough information around these so that if something like interests you, you can always go back and grab all the details on the activity from the website. This is a chicken cooler, which is used in poultry, and they run chickens through this cooling system. It's got cool water in it, and they run it through here in about an hour. So this thing is turning very slowly to process these chickens through here to get them from a hot temperature down to a cold for packaging. So the idea is you have a motor and a gear reduction to size this last driver sprocket. So what sprocket size are you going to need that's going to turn, oh, that popped up, a driven sprocket, sorry, this sprocket here, to make it turn 1/3 of a RPM, starting with a motor that's going 1725 RPMs. So it's just ratio and proportions, inverse though, because obviously the bigger the sprocket, the slower it's going to turn, right? This is matrices. I'm getting really short on time. So if you, very introductory, not a whole lot going on with matrices here, but a hydro rack has a ton of pieces to build it. And if you're shipping so many of them all over the world, how many component parts are you going to need to ship to all these different places? So you're building this matrix just to contain and hold all this data, and then you're constant multiplying it by things to get a part list needed. And the last one here is a fabrication company. And actually, this company has a plant in Virginia, Steel Fab. I don't know if any of you on the call have heard of Steel Fab before, but they have an office in Raleigh, but also I think they have their bigger manufacturing plant is actually in Virginia. Julia, do you know what city? Or
I don't know what city, but I know Grace, our videographer, has gone up there to video. So some of the video is from their Virginia.
Cool. So research them. They are a great industry partner for education. They just to highlight this company, they gave an entire school, teachers, TAs, administrators, a $50 Amazon card for a back to school gift. Just hey, we're coming back in this COVID situation. Can I do something for you? So they've been involved in education and supporting education. So Google them. If they're in your area, reach out to them because they're a tremendous company. They would send people to your classroom probably. I mean, they'll do anything you just about can ask of them. But the math here is not trig related. It could be based on trig if you changed angles, but we're just dealing with 45. So it's more Pythagorean theorem and using this complicated formula here that you're looking at to, and I didn't mean to do that. To figure out the thickness of the beam that's going to withstand all these forces for each floor. And obviously the further you go down, the more weight is holding. And it's a really nice fourth degree polynomial as it ends up there in that formula. But it's all dealing with finding the thickness of that beam is going to be required to withstand the force on it. Okay. Whew. I'm gonna stop sharing. I think we're about out of time anyway, if we already haven't gone over it.
We have
And,
2 questions in the chat also, Jay.
cool.
One is, what is a Desmos activity? And then the other, I'm reading the title, Connecting Industry to Mathematics, and this is a project supported by NSF. Is there an option for adaptation to implement your project in other colleges? Not within our grant that we wrote, but Jay, you want to answer that one?
You know, there are very few NSF-ATE grants that get funded to math because they just don't receive grants from math. So I think if you wrote a similar grant project, I would feel pretty confident that it would be funded, to be honest with you, because I mean, it's like less than 5% of grants that they get are math related. And they're all about industry. They're all about STEM, recruitment, and getting students into these 2-year programs. So, you know, go after it. Go after it. It's a ton of money. ATE is for community colleges. So that fund of money is strictly for what we do at 2-year schools. So any way we can help you, give you ideas. If you wanted to pursue a grant, you have our contact information. We'd love to share ideas with you and encourage you to go forward with it.
Desmos really quickly is just an online teaching tool. I use teacher.desmos to create activities for my students. But you can find all kinds of activities on the web about Desmos.
By coincidence, I'm giving a presentation teaching statistics with Desmos tomorrow. Yeah. So there you go.
There you go. You can learn more about Desmos tomorrow.
Is it the same as the Desmos calculator, or is it something else?
It's a little bit different.
They call it the Desmos calculator, but it's actually a graphing application. It makes makes graphs.
But the teacher Desmos activities, and there's tons of them already built that you can just steal and use. And if you're teaching virtually, they're awesome because, you know, it gives the student a grade. You can go in later and see the work that they've done and comment back to them. So, and it's, you know, it's free to educators. So it's a great tool.
Thank
I'm glad
you.
you mentioned that, Jay. I didn't know that.
Yeah, explore that one.